Hello everyone. Today in this video you're going to be learning what is a derivative, and this is a very important concept in calculus. This is used all throughout calculus, so it's very important to know what it is if you're going into a calc class. First things first, to give you the straight up definition, a great way to think about what a derivative is the rate of change of a function at a specific point, okay? And I have a video on functions, on what a function is, how you can test if your graph is a function with the vertical line test, okay? But so very quickly, if you have like some, I don't know, if you're actually writing notes on this, or if you just want, if you use your brain, this is the definition to remember, okay? The rate of change of a function at a specific point, okay? What is the rate of change? First thing we must do is let's take a look at the average rate of change. Like if we were to take a look at a graph, okay, and we wanted to see what the average rate of change is, we would use the slope formula, right? We would know this with using secant lines. And if we took a specific point, let's call this point X, okay? I'm going to erase this because we know that's the x-axis, okay? So we call this X, okay? And where is this point? This point is right here, okay? And then this right here, this point would be f of x, right? That's where that point is, okay? Now, if we took some distance, so this distance right here is x, but if we took some distance a, okay? So this is x plus a. That's what this distance is, okay? So let's just take, or how about okay, that's a little better. I'm probably not teaching this the best I can, but hey, at least if you get the concept, that's all that matters, okay? So, you're going to go out x, okay? And then let's go out another distance, a, okay? So this distance right here is right here, okay? So this is f of x plus a, okay? That's where that distance is, okay? So now, if you took these 2 points on your curve and you made a line like, that's not a straight line, but it is what it is. Look, if you made a straight line through there, okay, and then you took the slope of that line, which would be m equals y2 minus y1 over x2 minus x1. So in this case, that'll be f of x plus a minus f of x over x2 is just x plus a minus x1 is just x, right? So this formula right here, this formula is representing the slope of this. And if you notice on the bottom, you have the x minus x, so it is just a on the bottom, okay? Looks like a textbook definition of what a derivative is, where if you take a to be super, super small, if you move this dot closer and closer and closer, and you moved a right here, so you made a as little as you can, so we'll represent that. So the definition of it is the limit as a goes to 0 of f of x plus a minus f of x over a, okay? This right here, this right here is the definition that you can remember. It's the limit as a goes to 0, as this dot gets super, super close, and as you take this line right here, that's what's the slope of that line, because that line will tell you what the rate of change of the function is at this point, okay? So that's what a derivative is. Hopefully this video was helpful to you. If you want some practice problems on how to take derivatives and how to use this to take a derivative, and then how to use some easier ways to find a derivative, go ahead and check out the other videos on derivatives. But this is the textbook definition of what a derivative is. Thank you for watching. Hopefully you learned something, and we out.